Hi Sean, I've decided to do a small video rather than send you some notes on the use of R. I thought it's a lot easier really if you can actually see things. So I'll actually do a small demonstration using R and RStudio. I've also got a small presentation which is useful just to go through a couple of points before we actually start to look at some things on R. One sort of focus on is basically how you would start to think about learning about R, which when I started to look through things was a little bit more difficult than I thought. Courses and books don't quite work, so I'll go through that now. I'll start off by just going through a small presentation. Here we go. So I've called it a brief introduction to R for medical research. So I was trying to think about the types of things you might want to do for medical research and have focused the books are recommended on medical research books. The interesting thing about R was actually it was developed in 2000 in Auckland. I think at the same time, similar types of things were being done on machine learning, and now they're coming together. But because it was developed in Auckland, obviously there's quite a large take-up within New Zealand, but it's widely used throughout the world, and it really has got a good reputation. So the good thing about it is that there's lots of support online, and there's lots of developers involved on moving it forward. So in the last 20 years, it's come on tremendously. So it's probably a very different beast now than it was in 2000. And I'll cover a little bit of that now, and maybe some of the features that I'm going to recommend you use, or some of the newer ones that people are starting to use at the moment. So I've called it a practical approach to learning. So it's really the types of things you might want to think about as you start to plan how you're going to learn to use it. I've actually started with research principles, and the reason for this is to think about, depending on the type of research you're going to be doing, how you're going to be doing it, you probably have to tailor the way you learn about things and the way you practice things. So one of the books I've recommended is about reproducible R code, and it's a consultant who's written it, medical consultant who's written it. So one of the key things there is it's reproducible. I'm also saying you need to think about how you're going to validate it. One of the things in IT generally when you start a project is you work out really from day one is how you're going to test everything and make sure that everything works okay. And I've also put publish down there. So by published, I mean you might need to either create what we call a notebook for doing things. It could be a document you're going to publish or a research paper, and it could even be a book. Some of the principles are very similar. And it's also useful in actually keeping track of what you're doing yourself and auditing what you're doing. So we'll be looking at that. So what I've actually done is highlighted in blue the types of things that you probably need to put at the top of your list to consider doing. The things in yellow are the things that I would consider next. The white ones are general things for information that you might want to do, depending on where you want to put your focus, if it's slightly different than what I've assumed. The next thing to think about is really how are you going to do this? So are you going to be using a separate laptop or which is dedicated to learning about R? Either your own personal general laptop, and also whether you're going to use Linux, Windows or Mac. So if you've got a laptop that's got Windows or Mac on, can you use that? Or do you need to load Linux on it? And the only reason for that is that some of the courses that you can do, these small future learn courses that I've just done, and one was on bioinformatics, and they spent quite a lot of time, 2 weeks out of 3, on talking about Linux, which is the operating system, which is predominantly used in industry for the main computers. You can also have Linux running on your laptop as well, so you could buy a laptop and put Linux on if you wanted to. What I'm suggesting is that you don't really think about that too much unless you need to. I'd start off by just using general laptop with either Windows or Mac on, and then with loading R onto that. I'll explain what Linux is, and then if you need to do it later or you think it's important to, you can do that. A further consideration is that what type of statistics you want to do. Do you want to learn about general statistics that most people would use? Do you want to purely focus on medical, or do you want to consider machine learning as well? The reason that you need to consider whether machine learning early on is that it's a slightly different approach. You might need large amounts of data, more historical data, and you may need to consider what types of algorithms you use. Also, if you want a lot of data that's going to be used, depending on the types of data, you might need a different machine, because a machine that's designed for machine learning isn't necessarily the same as a machine that you might use, a standard laptop, depending on the type of data. It's not necessarily more expensive, but it tends to use more processes. So it'll be running lots of bits of data in parallel, processing them in parallel. So it's a consideration. But I would suggest you stick with general statistical processes you need to understand, and also look at a few medical things and have an understanding and awareness of what machine learning is, in case you want to include that in part of your research. But you can always pick that up later. Materials are a bit interesting. I've looked at a few books and also done 2 short courses at the moment. But I'm not recommending, actually, when you start, you use either. What I'm suggesting is you use a thing called Bookdown. And Bookdown is, within R, there's a way of collecting information and producing either a book or a report based on that information. And then it can either be produced in a book format, an EPUB format, or it might be one of the other formats used for books. Or you can produce a HTML document, a web document. What you'll be looking at is the web documents. And the benefit of that is, it is like reading a book, but you can click onto the index, but also you can copy chunks of code quite easily. So it makes life very simple. You can follow the book down, automatically copy chunks of code and move it into your or window that you're using and actually run the code, so you can follow through much more simply. So I'm just suggesting you do that. But also you might need to think about, when you start to publish things, it's the a thing called R Markdown you'll be using. But we'll be going to that later. So it's just an approach, and you'll see how that works well. So I'll be using that in a small demonstration later. So just to reiterate, the approach is use your own laptop, use whatever runs on at the moment, either Windows or Mac. We load R, which is the language we're talking about. We're using a thing called RStudio to run it. And that makes life a lot simpler, and you can see a lot more that's going on. There's some packages that have a bit more recent called Tidyverse, and we're looking at that. But it's a much more simplified way of doing things, and a lot of people are using it now. The 2 books that I've recommended both cover the use of Tidyverse, which is a set of algorithms. And then I've suggested Bookdown. And it just so happens that the 3 books I've actually picked up are all to do with Bookdown. Have all been created using Bookdown, and they're all free. And all you need to do is click on the links, or copy those links across, type them in, and you'll automatically go to them on the web. So the first one is R for Data Science, and that's the key book that you'll actually be using to learn about R. There's Reproducible Medical Research with R, which is a great book which covers everything that medics want to do when they're thinking about doing a research project. And I would probably run the 2 together, that maybe read through a little bit of Reproducing Medical Research with R. But when you're starting to learn, use the R for Data Science, because it pulls heavily on the R for Data Science and a lot of the notes. So if you've been through that book first and actually gone through all the examples, you'll have a good understanding about what it's talking about. It's a more straightforward way of doing it. And then if you need to start to think about how you're going to publish things and you want a little bit more information, then look at a thing called R Markdown. R Markdown is the way that we document the things that we're actually doing, and we create notebooks. And R Markdown then just goes into Bookdown to create actual books on the internet. So that's probably the, as far as I can see, the simplest way of doing things, and it is extremely simple to do. So the simple method. The two books I've recommended, the first two books, both cover how to load OR onto your laptop. And there's lots of documentation about how to do it. It's very straightforward. So the first thing you do is load OR onto your laptop. You then load RStudio, and RStudio is just this front-end user interface for looking at OR, and we'll be looking at that. And then install the package Tidyverse. I'm suggesting that because the first thing you'll find in the book that you'll be going through is the first thing they ask you to do is to load this Tidyverse. I'll go through what Tidyverse is on the next slide. So read, and this is over quite a long period now, I'm saying, this book on reproducible medical research with OR, and that can be a background task, reading and going through that. But also, your key book you're going to be reading and using is OR for Data Science, and you'll be copying code snippets from there into your RStudio and running them, so you can see how they run. And also, you'll be doing a little bit of playing around and altering some of the code to see what the impact and effect is. So use code snippets, including medical data from reproducible medical research with OR. So there's a few snippets in there which actually allow you to pull in some medical data. So that might be useful for later on, not initially, but after a while, it's something worth doing. And take a look at this OR Markdown, the definitive guide. Once you start to think about how you're going to publish things and how you're going to ensure that you've got reproducible data. And I say both books cover that anyway at a high level. This book just gives you some more detail. So I mentioned this thing called Tidyverse, and I thought you might be asking, what is it? And it's a number of very large packages, actually. The key one is called the ggplot2, and this helps you to plot graphs. So you can plot a wide range of graphs, and some of them look really professional. There's a lot you can do with it, and it looks like it's one of the main packages that people use. And that package, plus a lot of others, which are a similar sort of size, I've been including into a thing called Tidyverse. So they're quite useful ones. Another big one is called Tibble, and Tibble is, if you look at matrix of data, they were called data forms before, and now they're called Tibble. And what it's done, it's made it a lot simpler to use the data matrices. The others all to do with handling files, cutting files down, manipulating the data, cleaning up the data, reading strings of data. And it's all to do with how we're cleaning and manipulating data, each one of those packages. So they all do something different. Okay, so I thought I'd just show you the difference between Linux and Windows or Mac. So this is running, in fact, it's running on my Raspberry Pi, so I've taken a screenshot of it really. So rather than running the Raspberry Pi operating system, I've loaded Linux, and you can see that it's a similar sort of thing, isn't it, really, to Windows and Mac. But I've pulled out a terminal, so I'll show you on Windows later. You can actually run a terminal on Windows, and you can run it on Mac. And I'm loading a terminal on Ubuntu, Linux operating system, and you can see you can key in individual instructions in. That's used quite a lot when you use Linux. So the course I initially did, which was on bioinformatics, they're actually loading the data, cleaning the data, running instructions actually on this terminal, or some people call it a shell, on the shell. And you can do, I'll show you can do lots of things with that. Having said that, most of it can actually be done from the GUI front end, which is probably more common. Okay. And this is just showing another picture. So this is my laptop here, and you can actually run Linux as an application on your Windows or Mac. So certainly on Windows. So this is a Windows machine, and it's got a Windows app running Ubuntu. There's a number of different ways of doing this, whereby you can run a Linux window on it. It is a little bit tricky because from time to time, you do find that different versions of things get out of step and it doesn't quite work. So really, yeah, it's worth having a play with running a Linux app on Windows, but I wouldn't do all of your work on it. The other thing is there's a new version of this coming out soon, so it's probably in the next 6 months. I'd hang on until that comes out, then maybe have a play with Linux if you need to. So on with the show, and let's have another look at. I'll just show you a few things that might be of interest. Let's close that down. I think before we start, I did mention there's a thing called the terminal inside that you use on Linux. Well, you've actually got the same thing on Windows. I'll just show you and give you a feel for what these things are. So I've just right-clicked on there. You won't be using this, so don't really worry about it. Let's have a look now. It should say Windows PowerShell. It's called the shell now. On here. Yeah. It just takes a little bit of time to open up, and you'll find this on Linux as well. Okay, so they all look very similar. They have a slightly different commands. Some of the commands are similar on Windows to Linux, and others are very different. And what you can do depends on the operating system you can use. So typically, for example, it tells you where you are. You can see here, user Dave's. Yeah, so that's what my Dave's laptops are Dave's. I can type things like ls, and enter. And it gives me a list of all the directories. I'm not going through many commands. And then I can change directories. It has got a little bit of a language in this one. So let's have a look now. X equals 3 plus 4 divided by 2 plus 6 times 3. If you can work out what the answer is. Doesn't give the answer straight away, but if I do X, and it gives me the answer there is 23. So that's just showing you can actually type commands in, and it has got a simplified language. And most of these things, what they've got is you can actually type instruction by instruction, or you can create a small file and put a number of instructions in and run the instructions all in one go. On Linux, it's called bash. When we look at OR, we'll notice that OR runs in a similar sort of way to this. Now, the reason I'm actually showing you this is when OR first came out, it was designed to run in this type of window. So we'll be looking at the window, and then we'll see how different it is now. So the reason that people sometimes want to look at Linux is that they'll open a Linux shell like this, and then they'll use some commands to maybe truncate files or look for certain records in a file and pull those out into maybe a separate file, which they then feed into OR. But you can do all that in OR, so some people just like or feel they've got more control when they're using these windows. Okay, so that's the last time we'll be looking at that now, so just give you an idea. If we look at OR, let's have a look at now. Now, the important thing here is when you load OR, and I found there's an issue with OR and RStudio. If you get versions which haven't been produced at around the same time, there can be a bit of a conflict and they don't quite work. So try and take the latest version of OR and the latest version of RStudio. For Windows, it's all on a 64-bit machine, so around a 32-bit, which is this one here, and then the latest version of RStudio. I'll just show you all. Okay, so that's all. So it looks very simple, and as you can see, it looks similar to my Windows shell. It just gives you an area here where you can type instructions, or you can create a file and run files of instructions, and you can do more or less the same types of things that you can do on RStudio. So it's very similar. Okay, let's look at RStudio. These things take a while to come up. My machine's got lots of running on it as well, which can take a bit longer as well. There we go. Wow, look at that lot. I'll show you now. Let's just close this. Right. So what you'll normally find when you start is these 4 windows. So 1, 2, 3, 4. And you can press these here. So expand that, or reduce it. Yeah. So just change the size of it. Now, what each one does, this window here, see me moving around there, that's the same as the terminal or the shell window. And you can see you can type into there. That's exactly the same as typing into R. What you'll find here is when we start to do things and we want to maybe run some code that creates a graph, then the graph will actually appear there. So we can see both the code here and the graph there. This tells us the files that we've been opening, and I mentioned before that if you want to do something to do with artificial intelligence or machine learning and also some statistics programs, they always give you this iris file to start off with, and you can see that I've loaded an iris file in the past, so it's already there. This window here can actually display data and it gives you further information. So what was open when we started, and you'll see me here, it says iris there. Iris, yeah, that file is already loaded. So if I click on it, yeah, I can see what's in the iris file. So those are all the irises, and you'll see that we have different types of irises. Yeah. So the different species are down there. So basically what's happening is it's using a number of variables here. It only picks a few, and it's determining which species it is based on the length or the width of the petal or the spetal. Okay, so just close that now. So I said the key thing here is, isn't it? We'll be typing the code in there in the same way as we would when we're running on R. But there's a really interesting thing here which makes life a lot easier. If I look here, I've typed packages, so I've just clicked on the packages, and you'll see there, these are all inbuilt bits of code. If I nip down here, so they're all available, but they're not actually running in the background yet, so I need to make sure that they're running in the background. And this is just for efficiency. You don't load everything at once. And we'll see a thing here called Tidyverse. So if I click on Tidyverse, just click on it. All I need to do is click on it. Okay, and we can see down here that it's actually started, it's loaded Tidyverse. So Tidyverse is now available to us. Let's go up there. Okay, so I can see there, and it tells you it's gplot, tibble, tidyr, readr, per, dplyr, stringr, and forcats. So those are individual packages. And I say that the key one we're going to be using is this ggplot2. So we've got everything open. We're not really sure what we're going to do with it or how we're going to use it, but we've got this idea that the code comes in this window here. And the first thing we're going to do is make sure we've got the packages that we want to open. Now, some of the packages are already preloaded, but the only one that we are, or the group that we're going to make sure that we've got open is Tidyverse. So we click on Tidyverse, and we can see here that Tidyverse is now loaded. So we've now got R, and we've got Tidyverse. So now we want to go through and say, right, let's learn a little bit about R. Let's read the book and start to copy some code across. So just leave that. So I've got my book here, R for Data Science. So I'll click on there. The link. Oh, here it comes. I don't know if the internet's slow, it's just this machine. Probably need a new machine. I have to have a word with Kay about it. If you look up here, it says HTTPS R4DS for data science had.co.nz, right? And had, I think had is a repository of information as well, a repository of books. There's a thing in IT where you can store code, and virtually everybody uses it now. I can't remember which company's brought it up, but it's absolutely fundamental for everybody that does any programming or code, called the GitHub. And GitHub is this massive repository of code that people can work on or pick up. So if I'm working on my robotics projects and I want some code to run to manipulate a robot, it'll be stored in GitHub. So I need to download it from GitHub. The same thing is now applying to books. So these books are actually stored on GitHub. So when you think about who's written a book, if you actually look at the way that books are produced, and certainly these scientific books, what people tend to do is to use this a standard format, which is this all markdown in terms of R. They'll load it into GitHub and then allow people to go in and update and amend it. Or to take different copies of it. So you can have a lot of people all working on it or verifying things or maybe changing little bits of code there where you've got code in the book. So you can have quite a large number of people all working on the same paper or working on the same book, which is stored in GitHub. You can also do it by storing these things on this Bookdown. So if we just look at the book and we'll just see where were we now. Say data visualization. Okay, so this is a chapter on data visualization. Right, so all I'm going to do now is you can see here there's an example which says ggplot. Well, we saw on Tidyverse that the plot was called ggplot2, right? I'm going to use some data. And it's MPG, and MPG stands for miles per gallon. But it's actually, I think there's a data file called LPG. Now, where this file is that within ggplot, there are some example files that you can use. So rather than loading your own data in, the data's already been loaded. So there's a number of these example files you can use. And then what we're going to do is to plot that information. And you'll notice that it gives an X and Y label on there, and then should produce this. So just looking at that there, we're going to copy it. That's copied. And let's go down here and pick up my RStudio. Okay, let's go down here. You can see this bottom left-hand quadrant going into the. I'm just going to copy that. I'll paste it. So paste it in. For some reason it doesn't. I've got problems with my keyboard as well. It doesn't always paste. Anyway, so it's pasted there. So it says now gplot the data miles per gallon plus, and this is the format used in R. Really, if you look at the language, it looks a little bit difficult to understand. But when you start to use it a few times, you'll soon get the point of it and how it works. So this is saying there's a geometrical point here that you need to map to. And all it's doing, it's saying X has got the word DIS displacement there at the bottom and Y as HWY along the side. So if we run that, then you can see it there. And we can see the labels in. So all it's done, it's plotted X and Y from this file that was already held within the plot algorithm. So I said that some sample file, just picked up a sample file, it's plotted the sample file and it's put some labels on for us. So it's not done a great deal, but you can see how simple it is now. We can start to understand what these labels are and how the syntax is put together, and we can run it. And that's basically how you'll go through and learn about this. It's quite a bit easier than using a code. So I'm just coming back again. I've actually been typing a few things in and trying a few things. I'll just explain one or two things about the graph plot, which are fairly straightforward. The first thing is that if we want to know what data elements is being used, which we will, it tells you here. So you can look at the X is displacement and the W is HWY. And those are the column names on the data that's using. So the data file is called MPG, which we can see from there. And the X coordinate is displacement, I'm assuming it stands for. And then the Y is HWY column. So you can tell, you can pick out the different columns you need. There's a lot more to ggplot, a lot more different parameters you can put in there, and you can actually go if we go on to Tidyverse onto a ggplot, you can find all the information you're going to need on the different types of parameters and what you can do with it, and it's a phenomenal amount you can do. So let's just go back and we just have we look at one more thing. Down here, and make sure we're in the right place. Right, so that's where we were before. Let's try and copy something else across and do something fairly straightforward again. Find something. Oh, yeah, here's an interesting one. So this is virtually the same as before, but this time all we're doing is adding a little bit of colour to it. The reason I don't want to do anything too sophisticated is that on some of the examples you've got in the book, you need to follow it through. So you're actually taking a file, manipulating, creating a new file and doing some work. As we've not been through the earlier stages, you might find quite a few things don't work. But if you follow it through, it'll work fine. So I click here. So let's go back. Let's go. Look, where was I? And then missed it there. So I can go back here again and paste. There we go. Okay. And we can see down there that it's actually color coded, I think there. Yeah, and we can see all the individual labels as well. So two-seater, compact, mid-size, minivan, pickups. So, yeah, it's a nice little graph. So it's very, very simple. I mean, this example is very, very simple, but you can do a lot with it, and we can do quite a lot on manipulating data and then displaying it. A lot of the books actually cover how we take data, how we manipulate it, the different algorithms we can use, and then how we can display it. So that's quite a large element of it. The other element that you recommending that you have a look at is, let's go back here. Things like, there's a wrangle to introduce a few things to you. Yeah, it's this all markdown, and the all markdown is a method by which we can start to document things. And there's an introduction to it here, so it tells you about it here. And I said I'd recommend another book if you want to look at that. And it tells you the basics, so how we put a title on, how we pick up our individual snippets of code, and how we create plots. Yeah, and then there's some examples there of how it all works. So you can play through this later at some stage. It's not something you'll want to do from day one, but it might be something you might want to read through, because you need to start thinking about how you're obviously going to present the work and the results. So have a quick look now. Just some wrangling. Wrangling is a word that you'll be hearing all the time. And basically, wrangling is it's taking the data and manipulate it such that it's valid and usable. So you're cleaning up the data. You might be taking subsets of data. You'll certainly find a lot of data where there's missing information, and what you need to do is understand what you're going to do with this missing information, how you're going to handle it. you're certainly going to have elements whereby you're taking two files with data on and you need to merge them together, and it's not quite that simple because they don't quite line up. So you need to say, well, how do I manipulate one so that I can actually append it onto another? So think of different data sets and how we're going to handle it, and that should all be called handling wrangling. And you can see here, it also covers relational data which is stored in databases, or how would you pull information from databases in if that's what you need to do. So it's a pretty good book, and just take your time, work through it. This is the author data science, and at the same time read the other book, which is more focused on medical work. Okay, and I hope that gives you a good idea, really. So I think initially that's all I'd be focusing on, just going through these books. 2 books, Loading R, RStudio, and taking your time working through it and getting an appreciation of it, and maybe then do some further reading. And just give us a call if you've got any more issues with it, or any questions. Speak to you soon. Bye now.